Hello, in this video we're going to be looking at how to integrate partial fractions, and we'll be using the method of integration by substitution. So we're going to look at two examples, one of which is improper. That'll be the second example, and this is our first example. Evaluate giving the answer in the form ln a, the integral of 8x plus 7 over 2x squared minus 3x minus 20 between 6 and 8. And the first thing we need to do is to rewrite this as partial fractions. The first thing we need to do is to factorise the denominator, which will be 2x plus 5 and x minus 4. So our partial fractions will be a over 2x plus 5 and b over x minus 4. And we just need to work out what the values of a and b are. If we multiply through by 2x plus 5 and x minus 4, we get 8x plus 7 equals a times x minus 4 and b times 2x plus 5. So when x equals 4, we get 39 equals b times 13, so b is 3. And when x is negative 5 over 2, we get negative 13 equals a times minus 6.5, which means that a is 2. So if a is 2 and b is 3, then our partial fractions are 2 over 2x plus 5 plus 3 over x minus 4. So we can now rewrite the question as evaluate giving the answer in the form ln a, the integral of 2 over 2x plus 5 plus 3 over x minus 4 between our limits of x equals 6 and x equals 8. We haven't been asked to find the area, we've just been asked to evaluate it between 6 and 8, but we will get the area as shown on the right of the graph here, the area under the curve between the values of x equals 6 and x equals 8. So now we can move on to the integration and substitution. And although I haven't shown the working here, when we integrate 2 over 2x plus 5, we can use the substitution u equals 2x plus 5, and that gives us ln 2x plus 5. And when we integrate 3 over x minus 4, we can use the substitution u equals x minus 4, and that gives us 3 ln x minus 4. We could substitute the numbers in straight away, or we could use laws of logs to simplify the expression. So by turning the 3 from a coefficient into an index and multiplying, we have the natural logarithm of 2x plus 5 times x minus 4 cubed. Substituting 8 into that gives us ln 1344. Substituting 6 into that gives us ln 136. And then dividing 1344 by 136 gives us ln of 168/17. So we've evaluated it, giving the answer in the form ln a. So now for our second example, in which we have an improper fraction. So to start off with, we've been asked to find the values of a, b, c and d, such that x cubed plus 4x squared plus 4x minus 5 over x minus 1 x plus 3 is the same as ax plus b plus c over x minus 1 plus d over x plus 3. And once we've worked out those values, hence evaluate the integral of that expression. So firstly, I'm going to work out a and b by dividing x minus 1 x plus 3 into x cubed plus 4x squared plus 4x minus 5 using log division. X minus 1 x plus 3 is the same as x squared plus 2x minus 3. X squared goes into x cubed x times. Then we times the quadratic by x. We get x cubed plus 2x squared minus 3x. And then we subtract 4x squared take away 2x squared is 2x squared. 4x take away minus 3x is 7x. And then we bring down the minus 5. X squared goes into 2x squared twice. We times the quadratic by 2. We get 2x squared plus 4x minus 6. 7x take 4x is 3x. Negative 5 take away negative 6 is plus 1. So the values of a and b from the original question are 1 and 2. Now we need to work out our partial fractions. And we've got 3x plus 1 over x minus 1 x plus 3. And for some strange reason I've used a and b rather than c and d, but we can work with that. So the numerator of x minus 1 I have called a rather than c, and for x plus 3 I've written b rather than d. Multiplying through by x minus 1 x plus 3 gives us 3x plus 1 equals a x plus 3 plus b x minus 1. When x is negative 3, we get negative 8 is negative 4b, so b is 2. And when x is 1, we get 4 equals 4a, so a is 1. So it turns out that c and d are 1 and 2 just like a and b were. So we've now got our whole values of a, b, c and d, 1, 2, 1, 2, which means we've got x plus 2 plus 1 over x minus 1 plus 2 over x plus 3. And so to finish off, we just need to integrate it. The integral of x is a half x squared. The integral of 2 is 2x. The integral of 1 over x minus 1, we could use our integration by substitution with u equals x minus 1, gives us ln x minus 1. And the integral of 2 over x plus 3, again we could use a substitution like u equals x plus 3, gives us 2 ln x plus 3, and we stick the c on the end.